Hello, everyone, and welcome back. So here we are once again with the finalization of GetHeight implementation, but we'll call this part two, so that we were able to get this graphic function application up to demonstrate exactly what's going to be happening in the maths that Lee will be using.
Right. What I did is I brought up a little graph function applet that I found online, just to demonstrate kind of what is going on with our height map and how it relates to our terrain that we're building. Right now, we have a linear function. So basically, if we look at the x as the input that's coming in from our height map,
Now, in case you're
it,
using the mouse to point to anything, make sure you click inside the view.
okay, is it moving now?
Now it's moving.
Okay. So, but if X represents our input coming in from our height map and all of our blending and the summing that we did,
hmm
right up to this point right here where this value comes back out
hmm
prior to multiplying it by the max height.
Okay.
So if we get back to that applet, then what we're getting is a 0 to 1 value coming out of that function. So we're applying no scaling in altitude or multiplying by our max height in this case. Now, the nice thing about this is, we get exactly what we expect. The downside to it is it doesn't yield quite a nice result. We don't
Well, I mean,
have,
first of all, we're sea level right now.
well, technically, according to this, it would be at 0.5 right here.
There you go. Okay.
So right now, sea level is here. Everything above it is above ground, and everything below it is below, or everything below sea level is less than zero point 0.5. Now, the
Lee,
problem,
Lee, Lee.
yes, yes.
Everything below point 0.5 is below water. Okay, continue.
Okay, that works. Now, the problem with that is it requires that our artist with the base map go in and paint all of our beaches and get that nice soft transition into water and to land. Now, that height map is a macro level detail. It doesn't have fine beaches. What was the mathematic equation? Each it worked out to almost like 1 pixel, depending on our size, was about 12 meters across, I believe.
Yeah, something like that.
So that's not high enough resolution to give us a nice controlled transition into and out of the water. And then when we compound the fact that we're going to be applying random noise or pseudo-random noise based off of our noise map and our sampling, we can't really tell what's going to happen. We end up with the results that we had in the last video, where if it's still here, and it is, we get a very abrupt transition into water.
hmm
In this case, our water plane, I wonder if I can simulate it. Let's go ahead and create a plane. And I know it's here really somewhere.
Seriously?
No.
Seriously? There you
Yeah,
go.
I know it was there somewhere. Hey, my mouse was in the right menu, okay? I was just trying to figure out why it wasn't. I haven't used that lag card in a while.
I got you. Fair enough.
So if I center this up, and let's multiply this by 100 by 100. Well, that's probably a bit too big. No, I have no idea how that's drawing.
You could always just,
There we go. Type random numbers until I get what I want.
if you insist.
Now, because our height is being multiplied, I'm trying to raise this
You're
up.
moving in the
Yeah,
z-axis.
can you, yeah.
Yeah, let me help you out here.
Yeah, please.
No problem. So if we come over here and we move it in this direction, there we go. The Great Flood. No.
Right,
Oh,
now you should be
wait.
able to
You
get
moved
about
my mouse.
halfway.
Oh, here. Move the mouse.
So there we go. So water would be right about there.
Okay.
So still a very abrupt transition. And the way our height map was set with the ocean being a very flat plane, and I'm trying my best with the lag, we don't get much of an underground ocean underneath all this stuff. So it pretty much comes to a very abrupt end. So we want to be able to deal with this as
Yeah,
well.
but would you say right now that's because that's not really
An ocean,
put? Never mind.
and because it's a black map.
Con-
Oh, excuse
Continue.
me. What?
Nothing.
I'm
I mean,
curious.
at the end of the day, though, aren't you saying right now that the floor of the ocean is 0 and the top of the highest mountain would basically be 1? I know
Yes.
you've got a thing in there, but that means you really didn't drag the ocean up far enough.
Well, the ocean hit, if you
If
remember
we
in your
wanted to do the
Photoshop,
point, if we wanted to do the point 0.5 thing, I'm going by that.
right? If this was set to 0, and with this, black is 0,
Right.
and the brightest white is 1. Now, what we've done is we've shifted our black level. So now instead of black, we're starting at 64, which works out to, I'd have to get the calculator out for this.
Let's see. I thought I still had one up, but hang on. I got it for you. And yeah, that's what I thought was going to come in off screen. Okay.
So 64 by 255, we're coming in at 0.25. So
Okay.
there is, 25% of our available range being clipped off in this image to
Mm-hmm.
begin. So we're not seeing that full negative.
Yeah, true.
We're also not allowing the noise to take full effect at that point.
Mm-hmm.
So because it's a multiplication, and if our numbers are very, very small and you multiply by anything, you end up with a small number. So what we want to do is correct that. And the way we're going to correct that is by using an exponential function, which is where this comes in. Instead of this nice linear, for nice linear curve, and otherwise a straight line, we'd like to get some sort of S curve where the closer to 0 we get, the further below sea level we start to taper off. And we get a nice transition, almost like nice underwater beach and then a continental shelf and then the drop off that you would expect to see. Conversely, above 5, we'd like to see a nice gradual transition from the lowlands all the way up into the mountains where it curves up towards 1. To do that, we need an exponential function, which can be achieved in this case by using x times 2 minus 1. And what this does is it takes any value from 0 to 1, multiplies it by 2. So in the case of 0, times 2 equals 0 minus 1. So if it's a value 0, it's now negative 1.
We'll graph it out.
Well, yeah, I guess we could do that.
There we go. It makes it a little easier
Yeah.
with what you're explaining.
It's a graphing program.
Yes,
Wow,
it is.
look at that. All right. So what we've done is we've shifted our entire curve and extended the range from, instead of 0 to 1, from negative 1 all the way to positive 1. Still a very abrupt transition at sea level. We need to curve this out. Now, to curve it out, we can raise this to a power of 3. And if I grab this, we get the transition that I'm looking for.
Very
so
cool.
As we get close to 0, we get larger and larger negative numbers. And as we pass through or get to 5, we're pretty much flat. And as we go above 0.5, we start getting this nice gradual curve that steepens as we get closer to 1. And this gives us our high mountain altitudes in the highlands, but a nice transition down to sea level.
But at the same time, we don't really have a need for going that deep, do we?
Oh, like the Marianas Trench?
Exactly.
No. It's like going, well, mountains look really, really cool above ground. we really don't need the Marianas Trench. So what we're going to do is we're going to take anything that is below sea level and essentially um, divide it by 2. So
That's
it
right. So
only
the
goes,
deepest we'd be able to go
yep,
would be zero point 0.5, negative zero point 0.5.
right.
Okay.
So let's go ahead and do that. So
And
I'll
then for my
close.
awesome mountains, everything above would be multiplied by 1,000. Just kidding. All right.
Well, we could,
I
but
know that. All right. So let's just move this out of the way at the moment. You want to jump back over into some code?
yep.
Let's make sure that this guy goes ahead and stops just so that we don't make anybody unhappy. And there you go.
All right. So to pull this off, we're going to say height equals math f to the power, and then we'll take that equation that we were talking about, but instead of x, we're passing in height times 2 minus 1 and
To the power of 3.
to the power of 3. Space it out, hit semicolon, and probably helps if I type this right.
Yeah.
All right, so that gives us our curve, but we haven't done anything about what happens if the number is negative. So if height is less than 0, then we can sit there and go height divided equal 2, semicolon. And what I'm going to do is take our max height from here now, and I'm going to multiply it up here. So now we're going to take whatever height is, get our nice little curve from it, multiply it by max height, come down here and see if height is a negative number. If it is a negative number, we're going to divide it in half, and then we're going to return that. So if we build this,
Wow, look at that. We actually came right in on land.
right? Barely, but we're there.
All right,
Now, if you switch over to the scene view,
I'm trying. It just wouldn't give me the mouse. There we go.
so we're getting closer,
We are. Look
but
at that.
we've really, really knocked everything down. And it doesn't seem like this is a much of a problem here, but let's scale this all up to about the size of the world that we want to have in our game.
Okay.
So we're going to pause
Well,
this.
actually, right now, if you had water actually in there, we would have little beaches and all.
We would.
Because here we are underneath the grid, so
Mhm.
we're under the ocean, and here we are coming above it.
It's a really shallow ocean. You could probably wade, all the way across the pond and go to New York for New Year.
Probably so. So okay, so now let's start dealing with getting this guy. Whoa, hey baby, let's start getting this much larger now. Scaling
Right.
this all up.
So we're going to go ahead and adjust our scale. Again, this is magic numbers. Once you're done playing around, then by all means, replace this with a method, or not a method, but a function that calculates the scale based off of your number of vertices in your patch, your spacing, and then the size of your base map. So all of those can be brought in, and you can set that up as a final equation instead of having to type this inside of a calculator to get your size.
Right. And now, do you want to make any adjustments inside Terrain Patch?
Yes, I do.
Ah, I wonder how I guessed that. Because it makes sense.
Right. So now spacing of 1 is really nice for what we were testing just so we could show all the noise, but that's kind of a dense mesh for a game. So you probably want to, depending on your platform, go anywhere from a spacing of 2 for a PC type game. If you want something that is on par, if not higher res than a lot of the MMOs that are out there. If your machine happens to be a little bit slower, 3 or 4 works well. On an iPhone, you could go with a spacing of 8 or 16 even. So it smooths everything out, but it does work. So we're going to go with a spacing of 2 in this case. Now, let's go ahead and mess with the max height. I know Jason loves making this number as big as we can make it.
Well, mountains are interesting, so you know. All right.
So let's go ahead and
Is
build
that going to
this
be
up.
a little insane though?
At this point,
Well, yeah,
no.
we're so large now. Yeah.
No, at this point, it's not going to be insane yet. Matter of fact, it's probably going to be slightly
Oh,
on
the
the boring
death
side.
code is still there. I thought the death code was
Oh,
out.
no.
Wrong one. That's so awesome. All right, well, let's forget that and go back over here so that we can start looking at what we've got. There we go.
Right. But you're starting to notice something? With your grid example being sea level,
Mm-hmm.
we now have some really awesome underwater terrain. So instead of having that flat plane, all that noise is giving us some very interesting contour for underneath the waves. So if you're
Well,
making
also, let's not forget where we're spawning into the world at the map. If we were to look at that map as a much larger size.
right, if we were there, we're way down here. But
Like
if we
in
go into
the water,
Photoshop,
basically. Hang on, let me get you over there. So where are we at?
well,
Somewhere up in here?
well, if I do this, it makes it very apparent. Edit preferences.
Are you doing that on yours?
Hey, what do you know?
I'm just wondering.
Yes, I have Photoshop too, and I get confused from time to time. Um, wow, I have to close that. I can't even see your screen now. All right, hey, look, there's Photoshop. All right, so if we go to Edit, Preferences, Guides, Grids, and Slices, and we change this to percent. Let's go to 50% because we're spawning in
Mm-hmm.
halfway. So now we've got a bullseye. So if you want to zoom in there,
It looks to me like we are. Oh, so close! We just missed it. I was actually thinking we were out here in this area.
I can't see. Your mouse is,
Well, I can't help that, Lee.
yeah, well, you know.
Okay, so we are, I guess, coming in on land.
Right, so if we zoom in, let's turn that pixel grid off. We're coming in right here, but because we're doing some blurring in the way the noise is calculating in, that's pushed this underneath the water.
Right, exactly.
So not quite as effective as we want. Very cool looking, but we're under the waves. So the way we can control this is by taking our image and shifting our black level. So if we take this up to 96 and we go ahead and save this, so in essence we're raising all the colors. So we're pulling out our little almighty powerful hand and raising the landmass.
Let's make sure she's not too unhappy. There we go.
Yeah, she was re-importing the
Right.
new map.
All
So
right,
now we
man,
come
look at
out.
that. Hang on, let me go and switch on over to the. Yeah.
But we've run into another problem.
Where the hills go, Lee?
Yep, we've raised all of the landmass, but by raising the landmass, because of that curve that we're using, so everything that is close to 0.5 or middle level gray has been flattened out. So that doesn't do us any good either. So now I did it again. Alt tab does not work on my computer unless I want
Nope.
to switch my programs.
That's right.
So if you want to, let's see, can I get into Photoshop? Okay. So now if we take our gray levels and we push them to 128, in essence, what we've done is we've taken the ocean bottom, which was black, and we set it to 128 with actually 127 or 128 is close enough. Either one will be close enough to be essentially saying middle gray is sea level. So now everything in our map is at sea level or up. So now we have no oceans left.
Which means, due to the noise, if we were standing out there on the edge just looking out at the ocean, we would see little hills
A whole
coming
lot
up
of
and down.
You have a
Little
whole lot of
islands.
islands everywhere,
Yes.
which again, in this case, is undesirable. But we're pushing this up for dramatic effect, so it just looks cool having some decent mountains.
Mm-hmm.
But if that was the effect you're going for, you wanted mountains, but you still wanted to have oceans, you could come back in here and push down all these middle level grays to a darker color, and that
Absolutely.
would get you your oceans back. But we're not going to do it here. We're just raising the land for
Right.
dramatic effect. I love that phrase, dramatic effect.
Okay. Back over into Unity.
Yes.
Edit import.
Now we're probably going to be below and falling in this case.
Hey, I
Oh,
see a
came in.
mountain.
Yep. So now we've got mountains in the distance. And we probably even have some oceans back there. But those are little mountains. We're still not there.
Hang on, I'm zooming out. There we go. Yeah, those are the foothills. All right, so
Yeah, those are foothills.
let's go ahead and pause that and
But we're
stop
we're
them.
closer. We've now got our
Yes.
height map where we want it to be.
Mm-hmm.
Now to have some fun. Let's try that.
And falling. Whoa.
All right.
Well, actually, we're right where I want us to be. Oh. Definitely see some mountains coming about.
Yep, they're getting there.
Got some little peakies in here that we can talk about shortly, and seams all over the place.
Yeah, but those are normal seams, and because we're using just a
Whoa!
standard default shader,
Go ahead. I won't touch the mouse now.
well, actually, I don't even think I did. I wasn't quite sure what happened.
Oh, okay. Huh.
But we're using the default shader with no texture on it, so it's just white. So it's kind of plain. Let's see if we can do this. Now, I don't want to select anyone, but can I slide this over some? I would like this one file right here. Seeing as how so many people have seen the screenshots that we've had.
Mm-hmm.
I go ahead and drag this in, and then you try this. So now you can still see the seams, but they're less noticeable. Again, this is something that we'll address when we start getting into aligning the normals across the patches, and that'll come up with texturing. What we want to do in the next video, though, is we've got a lot of real sharp, pointy parts of our map,
Yeah, for sure.
and we want to take care of those.
Right, right. All right, so is that pretty much everything you wanted to cover in this one?
Yes.
Awesome. Well, with that, that is going to wrap up this video. Thanks a lot.